Okay, so I believe we can get started now. Um, so good morning, everyone. My name is Mohammed Hinai. Today I'm being joined by my colleague Inas. I am an R&D lead here at ISBAR. I am responsible for leading the research and development team through the design, implementation, and introduction of new solutions to the market here in Oman. Inas, if you may introduce yourself.
Assalamu alaikum. Hello, everyone. This is Inas Haddad. I'm a senior R&D engineer here in ISBAR. I'm working along with Mohammed Al-Hanai, and I'm having a background in electrical and computer engineering. So we both are working in introducing different technologies, which some of them will be presenting today for emergency response use cases.
Thank you, Inas. So before we get started with the webinar, I'll just give a brief introduction about the company, our company ISBAR. So ISBAR is a Omani-founded company. It's a fully Omani company, established in 2017, focused on a variety of drone-based and artificial intelligence services and operations. We currently work with a lot of clients in the oil and gas industry. And like I mentioned, we're focused on 5 primary areas of operation. This includes drones, artificial intelligence, IoT or industrial IoT, remote sensing, and software development. So these are the 5 areas that we currently operate in. And today we're going to be presenting specifically drones as first responders, mainly for emergency response use cases. So starting with the problem statement. So traditional emergency response solutions for monitoring rely on 2 primary factors. This includes extended continuous situational awareness, so being able to monitor the facility or the site continuously throughout the entire period of the emergency, in addition to dynamic perspectives and comprehensive coverage. This basically refers to being able to observe the entirety of the facility from different perspectives and obtain sufficient aerial intelligence to conduct your operations and coordinate your emergency response tasks. So I just want to give a brief introduction to what is DFR. So DFR stands for Drone as First Responders. It enables the utilization of drones as a first means of data collection. So during an emergency, deploying a drone as a first means of data collection is basically what we call a drone as a first responder. And compared to traditional aerial systems, drones, they possess advantage of quick deployment and operational flexibility. This basically means when comparing it to standard aerial systems such as aircraft or helicopters, drones can be deployed much quicker compared to these other systems or devices, and they're able to access areas which would otherwise be difficult when using standard or traditional methodologies. So at ISBAR, we're currently introducing DFR solutions, and we're splitting them into 2 different technologies. So the first one is using drone autonomous stations. This allows for immediate deployment through dynamic perspective capture. So basically what this means is autonomous drone stations provide us with perspectives, which solve the first issue. And tethered drones allows us to monitor the entire facility from a fixed position over an extended period of time. So it solved the second issue, which is extended situational awareness. So I'll give a brief overview about what a docking station is. So it's responsible for housing, charging, and automating a fully integrated unmanned aerial system, otherwise known as a drone. It allows for quick dispatch and data collection in high-risk areas, so it can independently take off and fly within these high-risk areas or emergency areas. And it eliminates the need of a pilot to be positioned within the operational zone. So the docking station allows for the drone to be deployed remotely without having to have a pilot in the field. And this subsequently reduces any associated risks with the emergencies. So currently, ISBAR, we operate multiple docking stations for emergency response. We utilize our docking station MISBAR 1, which is designed to be operated in very difficult conditions. So it has an operational temperature of up to 50 degrees Celsius. The dock itself is IP56 rated, and the drone is IP55, meaning it can operate in very dusty and rainy conditions without any interference. It's equipped with internal cooling, keeping the drones and systems cool even in very hot climates. It's equipped with automated smart charging, meaning it wirelessly charges the drone after it lands in the dock. and it has an endurance of 45 minutes, providing sufficient time to collect aerial intelligence and capture images and data, and a turnaround time of 27 minutes, which basically refers to the charging time of the drone. It's also equipped with an integrated weather station, so it assesses the environmental conditions prior to takeoff. If the weather, let's say, is too windy or too rainy for the drone, then it will automatically prohibit takeoff, ensuring operational safety. It's also equipped, like I mentioned, with the automated pre-flight check, which includes the weather status assessment, in addition to connectivity assessments and other forms of assessments. And it can be pre-programmed with certain flight routes, allowing for automated operation. And these flight routes are integrated with AI-enabled features, allowing us to conduct fully automated operation and reporting. So the drone itself is equipped with an integrated payload consisting of an EO/IR camera system, or electro-optic and infrared camera system. So the electro-optic system utilizes a triple sensor layout of 48 megapixels. It possesses 112x hybrid zoom, so it can zoom into all targets or objects from kilometers away. It's also equipped with a 1,800 meter laser rangefinder, which allows us to identify or pinpoint the location of certain objects that the camera is pointing at. And it supports as well full color night vision with the use of a near infrared auxiliary light. Now, when it comes to auxiliary payloads, the drone can be equipped with two different auxiliary payloads. The first one is an illumination kit, which is basically a spotlight used to point at the ground and illuminate the ground. It follows the camera, so when the camera looks up, the spotlight will look up with the camera. And it allows for a variety of fields of view, so it can focus on a certain area or it can do wide field illumination. The drone itself is also equipped with a broadcasting kit, which is basically a loudspeaker that allows us to relay audio in three different ways. The first is text-to-speech. So we can type in a sentence and the drone will electronically relay that. We can also upload pre-recorded messages, and we can relay our voice in real time. And the payload itself has 114 decibels maximum volume, which allows us to broadcast up to a distance of 300 meters. So how does the system actually work? So like I mentioned earlier, it's a fully automated system. So what the pilot would do is he would simply deploy the drone remotely from his computer, from his platform. The drone will automatically take off and head to the emergency site. It will collect visual data, thermal data, and all of that live video feed will be relayed in real time to the relevant personnel. And then once the drone completes its mission, it will return back to the dock, land, recharge, and prepare itself for the next deployment. Now, at any time during the operation, the pilot can also manually take over control to assess the situation further and make sure that he covers the area in a more comprehensive manner. The docking station as well can also be connected to various IoT devices. So let's say you have a temperature sensor that is set to a threshold such that when it detects a fire, it will be triggered. This temperature sensor can trigger the drone to take off during a fire and assess the situation prior to any emergency vehicles arriving at the site in order to ensure the criticality of the situation and assess the damage before sending human personnel to the area. So the various data types that the drone can collect during the emergency can include casualties, headcounts, and coordinates. For example, if there are a set of casualties or injuries, we can maintain a head count and identify the exact coordinates of every single individual within the facility. It can also determine the nature of the emergency and its criticality. So let's say you have a fire, we can determine the severity of the fire, the size of the fire, and understand exactly its position and location. And it's also equipped with automated temperature anomaly detection. So basically that means if any temperature exceeds a threshold that is preset by us, then it will automatically alert us. You can see here on the image to the right, a fire was detected in this specific area, and you can see the drone immediately alerted to us that there has been a fire in the area, and we received a notification. In addition to that, we can also inspect different areas such as emergency gate accessibility and entry and exit routes accessibility. So that would include if the emergency, for example, if the fire has obstructed the entry and exit routes and the emergency gates, and if there's any foreign objects and debris located within that area, you can collect all of this kind of data through the docking station and the drone. So this is a a brief demo of how the drone automatically deploys. Just a video we utilized to locate different individuals in a certain area. So the drone would notify us as soon as it detects individuals within the area. So let's say this is an emergency zone. We want to make sure the area is clear of people. We would do a quick scan of the area. And as soon as individuals are detected, we're immediately notified. The drone would stop and they're detected using artificial intelligence. At the same time, we would receive an email and a message informing us that there are individuals located in this facility, along with images and their exact coordinates. This is another example of it patrolling the perimeter. And as soon as an individual is detected, the drone automatically zooms into them, captures photos, records a video, and then sends us an email and notification informing us that there are people still within the site. Once the operation is completed, the drone will return back to the dock and automatically land. This is done completely without any human intervention. The drone would utilize its own RTK positioning sensors to position itself towards the dock. And once the landing is completed, the dock covers would close, and then the drone would begin charging, preparing itself for the next deployment. So moving on to the second part of our solutions, the tethered drones. Inas will be covering this. Please go ahead, Inas.
Thank you, Mohammed. Now I'll introduce another solution that we have, which is particularly valuable for emergency responses as well, which is the tethered drone. So unlike the conventional methods, the tethered drone is especially valuable for those cases because it's connected to a ground station instead of relying on the battery of the drone. So it will be connected through a tether or cable to a ground station, which will be managing the cable itself and the retracting of this cable, and then it will be connected to a ground station. Mohammed, if possible, to move on to the next slide. So through the connection of the tethered drone itself to a ground station with a cable, this will provide the drone itself with a continuous power. So instead of relying on the drone battery, which is maximum up to 45 minutes or 55 minutes in optimal cases, it will be enabled to fly for up to 12 hours continuously. So this will enable the operators in such cases or emergency drills, for example, they will enable them to focus on the situation itself, and they will be enabled to have a full situational awareness over the event instead of carrying or focusing on the battery landing and frequently changing it. So this boosts the emergency response safety and efficiency of the work. So when it comes to the advantages of the technology itself of the tethered drone, first of all and most important is the operational safety. So it enhances the safety of the first responders themselves in such situation and personals, and also it enables them to monitor the hard to access area, and also the control people who is monitoring the situation can have a live stream where they can monitor the situation even in hard, even if they are in office situation. The second thing is that it have an extended flight time. So instead of operating on the battery of the drone, which is 45 minutes, it will be enabled for up to 12 hours continuously. It reduces the downtime of eliminating the battery and changing it to a new one fully charged. And the last thing that is also most important is that the ease of use of such technology is very important in such cases, because the operators should not be bothered by the complexity of deploying the system, so it should be also easily deployed. So when it comes to the criteria of how we choose our tethered drone, because a lot of models are there in the market. However, when it comes to Oman specifically environment and situation, we need to have some criteria specifically designed for this environment and type of operation. So the first one is the environmental adaptability. So it should have a thermal tolerance, IP rating, and wind resistance that fits Oman environment. The second thing that the system must have a tether management, because imagine having a cable or a tether which is flying or bowing in the air, that would cause a lot of risks into the facility or operators there. So system must contain a tether management to reduce the tangling or the excessive drag because of the wing. It should also have a backup flight power battery. So in case of power failure, they also should have a backup to make sure that the monitoring of the situation is the system must be portable as well. So whenever the operators would like to deploy the system, they should have the ability to launch it in a fast manner. It should also be an integrable system. So it should be able to be integrated with different drone models and as well the payloads. So for example, for once it can be integrated with a camera. For the second could be integrated with a broadcasting for voice or light, for example. And the deployment time should be also short. So it could be deployed in, for example, 2 minutes, not more than that, because they should not be delayed over the important situation that's occurring at that time. And the cost as well, it should be not be the advantage of the system itself. It should have a cost value that reduce the risks that might occur in the situation. And last thing, which is still under the R&D, but we believe that under research and development, but we believe that once it's there, it will add a big value, which is having a vehicle follow mode. So instead of having the tether fixed in the ground, it could be in on the bed of a vehicle. While the vehicle is moving, the tether system can also move, follow the vehicle. So this will eliminate the challenge of having a fixed position. And the last thing is having a docked tether, where we have a docking station that is also equipped with a tethered option. So that would be an optimal situation where the same system can be unified into one solution for multiple purposes. So when it comes to the solution that we have currently in Aspire, the features and capabilities that it's first of all supported with live streaming capability. So through a dedicated link, all the operators in field or on site, that they can have a shared secured link where they can monitor, and also in coordination with people on site, coordinate how the operation should be. And it's also supported with AI features. Those AI features could be, for example, people counting, some kind of incidents. So this will make the monitoring and control over the situation smarter and more intelligent. So the operators can have an automated alerting system to any type of incident that require deep intervention. The second thing, that our system is supported with versatile payloads. So it can be equipped with cameras that is visual and thermal for night vision. It can also be equipped with floodlights. So for example, in such situations where there's, for example, no lights, it could be at night. So the drone itself can be used as a light system to enable the operators to have a vision in such areas. It can also be equipped with a communication relay. So imagine in such situation, and it can happen, for example, when the network can be shut it down. So the drone itself can fly and work as a relay to have the communication of those, they have communication enabled in those areas. And also it can be equipped with multiple other payloads, but those that we recommend specifically for the emergency response payloads. So when it comes to the tether length, it's important to have a tether length which is high enough to be able to cover a larger area. So the system that we have is enabled with 110 meters of lightweight tether. So first of all, this enables a good communication. So we'll have a speed live streaming through the camera feed. And the second thing, we can fly to a certain height that enable us to monitor a wider area. Earlier, it's also supported with automated tether retraction. So this is specifically for better cable management, especially for the high winds. So when there is a lot of wind, high wind in the area, the cable itself tend to have a bowing, so it keeps pulling because of the wind. However, with the management of the tether itself, we are enabled to maintain a safe position of the cable over the air. The design as well is specifically customized to have it portable. So wherever the operators would like to deploy it in challenging environment, it wouldn't take a lot of time out of them to have the deployment. So as I mentioned, when it comes to the system, one of the most amazing thing is that the system itself is integratable with multiple drones and payloads as well. So as you can see, not only that it can be integrated with multiple payload, it can be integrated deployed at the same time. So we can equip the drone with a camera. We can equip it at the same time, as we can see on the image, with a floodlight and a broadcasting payload as well. So the drone itself will work as a unified system to enable lighting, visual awareness to the operators, and at the same time with a broadcasting payload, which will enable, for example, to send a very critical or important message to certain people in the area. So when it comes to the specs of those payloads, specifically when it comes to the camera, we use a H30T payload from DJI, which is one of the latest and edgy camera types because of its specs. So it's a 48 megapixel RGB camera with 400 hybrid zoom. This enables the drone to zoom to objects that are 5 kilometers far away, and we still can see the details. So the drone is at a fixed position. However, because of those specs of the camera itself and the zooming capability, we are able to cover a 10-kilometer diameter area, even though from a certain position. We will see that in the next slides. We'll have a demo showcasing how those zooming capabilities are. The second thing that is, we're also equipped within the same payload, which is a thermal camera, which enables the night vision, or for example, understanding the thermal signature over the area. It could be, for example, fire in a certain areas. We are able to monitor all those dangers. So it is 1280 by 1024 resolution. And it has a range finder with ranging up to 3,000 meters. So whenever we want to range anything at a distance, we are enabled to do that within 3 kilometer area. And the last thing, which is very important also, which is the AI enabled subject tracking. So the payload itself are enabled to track, for example, to keep tracking a certain moving object. For example, it could be a car or a person, based on a predefined, for example, anomaly or a subject. The AI are enabled to track those subject based automatically without any human intervention. And as I mentioned, it's also supported with the broadcasting, illumination, and relay payloads. This is a demo showcasing how the tethered drone operates. This is a demo was done in our testing field in Misfell. As we can see the timer on the top right showcasing how fast the system can be deployed. Basically, the operator connects the tether system, which is in the middle box, to a power source. It could be a ground battery bank, or even ground outlet, or even a car. A source from the car, and then through the cable it can be connected to the drone, and the operator can just as simple as flying it to a certain desired height and leave it there for up to 12 hours. So as we can see that in this case, the operation took only 2 minutes to deploy the system. This part shows the live streaming. So as we can see to the right, the increase of the endurance of the drone, usually it can show up to 35 or 55 minutes, but in this case the estimated flight time increased to up to 300 minutes. Was scouting over the area. Now the drone will zoom to, as you can see, those tanks. Those tanks are actually 5 kilometers away, and the specs of the camera that we use, the H30T, enabled us to still see the details, the name of the tank, the label, even though it's actually 5 kilometers away. So this is the real view of the drone. This just shows how amazing the camera is, and how the technology right now can, even though of the limitations and the challenges, we are still able to monitor these faraway assets. Another solution that we also have that add a very interesting value, which is the cargo drone. Cargo drone basically that we, instead of relying on cars or people to move a cargo, we can use drones to do that. Sometimes some people might think that why would I use a drone and a very like high value technology for such, but in such cases, specifically in emergency response where we want to move a very critical deliveries, for example, first aid, or for example, when we want to move things at night or to a certain position which is in a remote area, mountains, it could be. So using drones would be very efficient when it comes to the deployment time, because imagine if it's a car, you need to pass roads. There is a lot of limitations when it comes to the ground, but when it comes to the sky, the drone can just fly immediately through a dedicated path. So this reduce the deployment time, the delivery speed as well, and the operational flexibility as well. Sometimes you don't have the resources to move things. In such situation, people can't tolerate that. But when it comes to emergency responses, first aids specifically, those situation requires a solution that can execute the mission without a delay. So the cargo drone is an optimal solution for that case. Now moving on to the project that ISPAR have, alhamdulillah, successfully conducted, was a very high emergency drill level, which is a drill of level 3 in an oil and gas facility. In this project, we were able to successfully validate and test both solutions, which we believe both of them are complementary. We tested the docking station and tether drone for different purposes, to be able to monitor the situation, and also having a scouting. The tether drone were used to do a continuous monitoring for the whole drill event, where the docking station were used to scout and do people counting and injuries counting as well. So as I mentioned, as you can see, the tether drone was flying continuously for almost 5 hours to monitor the whole event from a fixed position. It was equipped with the thermal camera for visual and thermal camera for monitoring the situation, as well as providing a thermal monitoring over fires or any other anomalies. And the entire drill was live streamed through a secured password locked link, so not anyone can access those links. Only people who is permitted with a certain password can access and have monitor over the situation. When it comes to the docking station, in the other hand, were used to allow us to have a scouting. So some angles, some positions required to have a scouting over the area to identify casualties. And AI was used as well to count the people there and continuously monitor the individual over the area. So both the dock and the tether system were used to complement each other. Each one of them provided a very valuable value for the drill, and the nice thing that both of them are enabled with AI and the recording system. So whenever any event occurs, a timeline was recorded, and a direct report or alarming was enabled as well. So when it comes to the DFR stations or system, the main added value of those systems that, first of all, it eliminates of on-site personnel. So this is one of the most important things, that we don't want to risk people lives in these situations. So the docking stations and tether drone eliminate the need of, for example, the responders, the emergency responders or the police, for example. They can still monitor it, but through drones. It also improves the perspective. So instead of having the perspective of a human vehicles, drone can have a very improved and more wide perspective of the situation on those areas. It also increases the operational efficiency because of the improved perspective and the ability to not only the operators to see the situation, also the people who's in control. From officers, for example, they have on hand decisions and they are enabled to see. So this will end up in increasing the efficiency of the operation, and all of that increase the response time. So whenever you have a better situational awareness, you will be able to have a response to the incident in a better manner. And the last thing, which is real-time relay. So they are all end up in reducing the overall cost of money, of lives, of facilities, damages as well. So whenever you look to at using drones at emergency responses, from our perspective, they are adding a very high value. When it comes to the use of those solutions, it's not actually only limited to the emergency response, even though we consider it the most added value or higher value. But there are a lot of other use cases that those systems can also be used and be pretty beneficial. So for example, security patrols. So whenever, for example, we have a facility where we want to have a routine patrols and an automated reporting, docking station considered to be an optimal solution. So instead of deploying a team there on the site, you can just leave the drone docking station with a drone on it with an automated reporting or path to fly. Um, you can leave it there and fly it autonomously without the need to any human intervention. Also, a routine facility inspection, for example, tank, flares, and general facility inspection. This is specifically added value for oil and gas, where the criticality of those facilities requires a continuous monitoring to make sure that all the operations are going as expected. Also, construction monitoring is one of the niche way to use docking station and tether drone. So the management team or the engineers who are monitoring the construction, instead of relying on a human, you can have a docking station or tether drone fixed there at a certain position, continuing monitoring those areas utilizing AI, and then having everything automated through a dashboard in order to manage the timeline, the resources, how things are deployed, if any violations are or misuse, for example, or any concerns or risks, all of those can be detected, reported, and visualized to the engineers or manager through a dedicated dashboard. And the last one is, as we mentioned, is emergency response, because of the value of having the ability to have an immediate situational awareness over those situations.
All right, thank you very much, Ines. We'll now be opening the floor to any questions. So please, if you have any questions, please feel free to write them in the chat, the Q&A section, and we'll be happy to answer them. Now we'll give a few minutes so that any questions that are available will be sent here. If not, then we can conclude, but we'll give a few more minutes for questions to be provided. Okay, so we have a question regarding the cargo drone. So the question says, how many kgs can the drone take for cargo? So we have a variety of different cargo drones depending on the specific use case and type of payload. The cargo drone's capacity can range from 330 kilograms to 300 kilograms. So there's a lot of flexibility depending on the kind of cargo. Okay, I have another question. Any plans for collaborations with delivery companies to use some of Aspire solutions like how Kita, Talabat, Careem are doing in other countries? That's a good question. Currently, our main focus for delivery is within the oil and gas field, as it's the highest potential for benefiting from cargo deliveries. Um, we currently did sign with Masar Petroleum, and we conducted the first cargo operations in the GCC with Masar Petroleum, and also we recently signed with the CCD as well. So we are already in the process of collaborating, and we're planning to further expand this and grow to cover additional markets as well. I have another question here. Have you had any real emergency cases before where you used both techs? What challenges with regards to using the tether one? So we did have one case where we used where we were required to conduct search and rescue using the emergency response drones. Um, One of the biggest challenges I would say is being able to cover vast areas. But this is quickly being solved by extended range drones. Battery technology is evolving fairly quickly at the moment, and we hope to see drones that can hopefully in the future cover hundreds of kilometers in one flight. So it is also very important to match the correct drone to the correct use case. So let's say you have an emergency where you would require to cover a large area, then you would deploy, for example, a VTOL fixed wing drone instead of a multi-rotor drone in order to cover larger areas. If you have areas, or you have, for example, a smaller, more compact facility within a range of 5 kilometers squared, then I would deploy a multi-rotor drone such as Misbar 1, which we showed earlier. So the biggest challenge is being able to understand what system to match for what emergency or specific use case. So I have another question. Do you have a multi-vendor fleet, and how do you address different drones or use cases? So yes, indeed, our fleet covers a variety of different use cases and drones. So we have, for example, the multi-rotor drone, which we showcased today. We also have a variety of fixed-wing drones that can cover hundreds of kilometers per flight. And we also have helicopter drones that can cover the gap in between. So more flexibility in deployment, but can still cover a large range. So these multi-rotor drones, like we mentioned, can cover between 30 to 45 minutes, and when in tether mode, they can cover multiple hours. Or we also have the fixed wing on VTOL drones, which can cover hundreds of kilometers and can fly up to 11 hours continuously. Also note, we'll also be providing a link. If you have any private inquiries you would like to send to ISBAR, we'll be happy to answer them as well through that link. If there are no further questions, I believe we can conclude. Thank you, everyone, very much for joining us today, and we hope to see you soon in the next webinar. Thank you.